Hi, everyone, and welcome to a new chapter. This chapter is about indices and surds. And indices we've learned a lot about, and surds you actually know a lot of background about how to work with them too, but we're going to review what we know already before we jump into new material. So this should be mostly background that you're familiar with already as we go through this part. You might want to pull out your notebook and take a few notes as we go along, and you can always pause the video as you're listening before if you want to write something down. All right, let's get going. So our aim is to remember what we've learned and to have a background about roots and indices. So we hope that by the end we will feel like I can calculate with roots and integer indices, including estimating an answer. First keyword that we need to remember is what is an indice, or another thing that we call it is an exponent. An exponent is the number that's positioned above and usually to the right of the base value. What it means is that you repeat multiplication more than one time. And another word for this is an index. The plural form is indices. And also sometimes we call it a power. So all three of those things, exponent, index, power, those mean the same thing. A quick example, if you have something that's repeated like 2 times 2 times 2, then we can write that as 2 to the power 3. This is the index, the exponent, the power, and this number down below is the base. It is the number or the term that has been multiplied over and over by itself. So if you have a square number, that is the product of two repeated integers. So if you have 2 times 2, then you get the outcome 4, and that's called a square number. You know lots of square numbers. 5 times 5 is 25. There's many others. A cube number is when you repeat and multiply an integer by itself 3 times. Like 2 times 2 times 2 is 8. Or 3 times 3 times 3, or 4 times 4 times 4, like that. If you have 5 times 5 times 5, that equals 125. So those are called cube numbers. So what we want to do today is we want to review powers and roots, and then we're going to talk briefly also about how do we estimate square roots if we're asked to do that. Perfect square, most commonly called a square number, is the product of two repeated integers, like we just said. If you have something like 2 times 2, that makes a perfect square. So 4 is a square number, 25 is a square number. What are all the square numbers we're going to think about? So first of all, we can write a calculation to find square numbers by rewriting it as something squared, something to the power 2. So 2 to the power 2, 5 to the power 2. Those are how we write squares. If you're familiar with the most common square numbers, it will make your calculations much quicker in the future. You'll be able to start to recognize these square numbers. And most of them you already know from your multiplication tables. I would recommend that you make a chart in your notebook and write down this chart and see how quickly you can fill it in. So what we're doing is we're figuring out, well, what's 1 squared? What's 2 squared? 3 squared? 4 squared? Like that. And then we're writing down what is the square number. So you can fill in all the way up to 15 and then just start to write them down. Now you should try not to use your calculator as you're doing this, okay? At least at first. Once you've written them down, maybe you can pause the video, fill in this little chart. It doesn't have to be perfect, but these are square numbers if you want your title. And these are ones that you really should be familiar with. So, for example, 1 squared. If you've done the work now and paused it, now you're ready to check your work. Let's do that. 2 squared is 3 squared, 4 squared, 16, 5 squared, 25. Okay, those are very, very common, the ones up to 5. 6 squared is 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared is 100. These ones are also very common and they come up in your times table, so hopefully you know these ones. Recognize them very quickly. 11 squared is 121. 12 squared, 144. Now these last three you might not have memorized, but if you would start to recognize them, it will be helpful to you in work on indices. 13 squared is 169. Then you have 14 squared and 15 squared. Okay, you've filled in your chart now. Now I have 4 questions here that I want you to again pause the video and write reviewing powers and roots. That's your little title. And then write A, B, C, D and see if you can come up with answers to how do you work out these. Now really you should be able to do these in your head because all of the squares, if you need to refer to them, you just made a chart of them. Okay, so pause the video and take a few minutes to come up with some answers here. Okay, welcome back. Let's check our work. Hopefully for A you got 25 plus 4 plus 10 equals 39. For B, 64 plus 16 minus 10 is equal to 70. For C, 100 minus 36 minus 64 is equal to nothing. Now this last one, you have to remember your order of operations. What do you do first? Do you do the adding or the dividing? Yes, you have to do the dividing first. So 25 plus, but you can't just do 25 plus 100 divided by 4. You have to do the 100 divided by 4 and then add the 25. And it will end up bringing you to 50. Okay, great. Hopefully that is familiar to you and you remember doing square numbers before. A cube number, or sometimes called a perfect cube, that's when you do something 3 times. So for example, 2 times 2 times 2. So 8 is a cube number, 125 we said is a cube number. What are some of the other familiar cube numbers? We write cube numbers by putting an index of 3. So 3 times 3 times 3 would be a cube number also. But what is it? What are those numbers? These might not be as familiar to us, but again, knowing the cube numbers will help you to work quicker through calculations. So could you fill in the table that I'm going to show you and put in all the common cube numbers? Now we're not going to do every single number the way we did with squares. Let's just do 1 to 5 and then 10. So make yourself a little chart. These are called cube numbers. You have your chart of what you're calculating on the one side and then what is the cube number answer. Okay, pause the video till you come up with your answer. Okay, welcome back. Now you can check your work. We have 1 cubed is 1. 1 is actually anything, no matter what the power is, it's going to be 1. Even 1 to the power 0 is 1. Okay, 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Now why I made these ones a special color is that 64 is unique. If you remember, it's also 8 squared and 4 cubed. So it is both a cube number and a square number. 1 is also that, but 4 is a unique number that way. A 5 cubed is 125. And you could memorize 6, 7, 8, 9. You'll see them sometimes, but they're not as commonly used. You will see them sometimes, but what is 10 cubed then? Definitely we should know that that is 1,000. All right, same way we worked out before. Pause the video and write down these questions and see if you can come up with an answer to each one. Okay, so you can pause the video. Okay, welcome back. So for A, 5 cubed is 125 plus 2 squared is 4 plus 9 is all equal to 138. Second one, 4 cubed, 64 plus 4 squared, 16 minus 100 is equal to negative 20. Okay. The next ones, the next two, again, you need to remember your order of operations. So don't forget that multiplying or dividing come first, and then adding and subtracting after that. If you do that with the part C, you'll end up getting 251. And for D, you'll end up getting 84. And if you have questions about that, please do talk to your teacher and ask, okay, what am I getting wrong, or how do I be more secure on how I'm getting these numbers? These familiar cubes and squares, hopefully you can start to work with them without always using a calculator, because sometimes you may have to work with them on your non-calculator papers, and also it'll just speed things up so much more quickly if you recognize what the base and what the outcome is for the squares and the cubes. One of the reasons why we want to know the answers is because on the flip side of powers are square roots or other kind of roots. So let's just look again here. When we were doing the squares, the square root of a perfect square is what was the number that was multiplied by itself to give that perfect square. So what does I mean? What does that look like? Well, 5 squared is 25, but the square root of 25 is 5. That's the thing that was multiplied by itself to get 25. Or if you said 36, the square root of 36 is 6. And we use that little check mark with a line above it. That's to represent a square root. So we say the root of 25 is 5. The root of 36 is 6. What are these roots? Can you take a minute and fill them in or say them? You should be getting these answers. You can check. Okay, here's some questions to try with roots, just to see if you recognize the common roots. If you've memorized the squares and the cubes, then you should start to recognize these roots. So this is reviewing again. Work out the following. You can pause the video and take a few minutes to try these ones. Okay, welcome back. So hopefully for A, you got 5 plus 12 equals 17. For B, 10 minus 9 minus 1 is equal to 0. For C, 4 minus 1 is equal to 3. Now with roots, there's a couple things that we need to keep in mind. If you would plug into your calculator the square root of minus 100, you're going to get an output something like this, math error, or cannot compute. Why is that? Why can't I take the square root of negative 100? If you want to pause the videos, maybe one or two people can share. What do you think? Why can't we Take the square root of a negative number. Okay, did you share your ideas? Well, you can't take the square root of a negative number because all square numbers are actually positive. And there isn't any real number that you can multiply by itself and get a negative number. Get a negative 100, for example, in this case. There's no two things I can multiply by and get negative if they're exactly the same. Because a negative times a negative is positive. And a positive times a positive is positive. When we start to work on other roots, like cube roots or fourth roots or fifth roots, we use a little number to represent what is the root that we're talking about. So if you were asked to do cubed roots, they relate to cube numbers. So the cube root of 8 is 2, the cubed root of 125 is 5, and we write it like this, 3 with the square root sign, but it's the cubed root, or the cubed root of 125. Can you fill in the rest of these calculations? Take a couple minutes, say them together. Pause the video. Okay, welcome back. Cube root of 1 is 1, cube root of 27 is 3. All right, here's some more to try. Here are 4 more questions. You can pause the video and see if you can work out the answers to the following using your knowledge of square and cube roots and perfect squares and perfect cube numbers. Okay, so you try them and then we'll correct our work together in a few minutes. Pause the video. All right, welcome back. Cubed root of 125 is 5 minus cubed root of 1 is 1, so the answer is 4. For B, you should get 18. For C, you should get 12. And for D, now here's this thing about 64, that it can be a cube or it can be a square root. Both of them work out evenly. What would you get here? 4 minus 8 equals minus 4. Okay? All right, just a few more ideas yet. If you put into your calculator, let's say there's a girl named Laura, and she inputs this into her calculator, the cubed root of minus 1,000. Well, Jim is looking at this, and Jim says it will give an error. Explain why Jim is wrong. Or if you think he's right, you can explain that too. What do you think? Why does Laura puts this into her calculator. Jim says it's going to be an error, but Jim isn't right. Okay, well, hopefully you know that cube numbers can be either positive or negative, because the cubed root of a negative number is possible, because if you multiply a negative 3 times, that gives a negative number. Like minus 2 times minus 2 times minus 2 is actually going to end up being minus 8. So you can get a negative number with a cube, negative or positive. All right, so we've reviewed the basics of powers and roots, and what we want to just talk about here yet briefly is estimating square roots. Sometimes when you're asked to estimate means you're not calculating it, right? You're just trying to get the closest thing. If you're estimating square roots, keep in mind that you need to estimate to the closest perfect square. And then think from there and make your adjustment. Okay, here's what I mean. So if you had these roots, root 1, root 2, or root 4, the root of 9, root of 16, square root of 25, where would they be on the number line? What are they equal to? they're equal to 1, 2, 3, 4, 5. Now, if you were asked to get an estimate of a root that doesn't work out perfectly, like for example, where do you think the square root of 10 would lie? It's going to be somewhere in between the root of 9 and the root of 16, which means an estimate of that would be somewhere between 3 and 4. Now, do you think it's closer to 3 or closer to 4? It's definitely closer to 3, right? 10 is closer to 9 than it is to 16. So as you're making an estimate, then you'd want to estimate something closer to 9 than to 16. So you might, as long as you have something less than 3.5, the midpoint between 3 and 4 is 3.5, it's probably going to be a lot less than that because it would be right next to the root of 9. So maybe 3.1, 3.2. There could be an infinite number of good estimates for the root of 10 as long as it's more than 3 and certainly less than 3.5. So that's just a quick review of how you could estimate. Let's try 3 of them. If you had to estimate to 1 decimal place these values, what would you estimate that they might be? Can you pause the video and try it? Just 3 questions. Okay, so for A, if you have the root of 8, what is that closest to? That's close to the root of 9, which is 3. So any value greater than 2.5, less than 3, so maybe something like 2.8, 2.8, 2.9, something like that. What about the square root of 18? What's it close to? It's close to the square root of 16, right? So something greater than 4, but probably less than 4.5 because 18 is much closer to 16 than it is to 25. How about the square root of 96? Now here you have to remember your perfect squares. So anything greater than 9.5, but less than 10, because it's close to 100, but it's quite a bit more than 81, which would be 9 squared. See how you do that? So hopefully that helps you to feel like you remember the basics of what we've talked about with perfect squares, cubes, and with estimating a root. So the root of a perfect square is the integer that's been multiplied by itself to give that number. And square numbers are always positive. The cubed root of a perfect cube is the integer that's been multiplied by itself and then again by itself again to give that number. So cube numbers can be positive or negative. That's what we said. And when you estimate the square root of a number, think of closeness to another perfect square and estimate from that. That's all we're going to do for today, for this video. And we'll jump into the next idea. We're going to be reviewing the laws of indices, which were done in 8th grade. All right, that's what we're going to do next. Okay, have a great day.